Hi guys, welcome back. In this session, we are going to understand what is meant by trees in detail. So in day-to-day life, we will be going to operate file system in our computer. You can see the file system here. So basically, you have a root folder inside documents, pictures. You have separate folders. So inside the documents, you have working folder. You have personal folder. Inside the pictures, also you have some picture and you have some family folder. Inside you have some family pictures, personal. Okay. Now inside this work, you have some files, separate files. So this is the way how you organize your file system in your laptop, okay, or in your desktop. So in the similar version, if you want to represent the same stuff in the format of this a tree, so this is known as a tree. Okay, this structure is known as a tree. So this is the hierarchical manner how you represent the data. Unlike the stack, array, linked list, these kind of structures are known as linear structures. Those are will be in the straight line, but the trees and graphs will not be in a straight line. That will be hierarchical and it will be a non-linear structure. You can read over the definition of a tree here. So a non-linear structure, a hierarchical data structure used to store and organize efficiently for operations like searching, insertion and deletion. Okay, unlike linear structures like array or linked list, trees have a branching structure. So yeah, in regular life we see the trees, right? So the same way in the programming language concepts also we name it as trees only, because we have one root, it is like a tree, so that's why we name it as a tree. We have branches coming down, so it's branching structures we can understand. So if you can see clearly over here, we have a data structure. So basically now I am explaining what is the structure of the tree with the help of this tree diagram. Yeah, the tree is explained with the help of this tree only. So the data structure is there. We have two types, linear structure and non-linear structure. In the non-linear structure, we have trees and graphs. In the linear structure, we have static and dynamic. So static, we have arrays. Dynamic, we have linked list, stack, queue. So already we have covered these three concepts in the previous sessions. Please see that. So if you see clearly in the trees, we have each and every important concept that I am covering here. So we need to understand some of the related terms here in the trees. So we have node concept. So what is meant by node? So each and every node which have contains three parts, which is data, left pointer, right pointer, is known as the node. So what is meant by root? So basically the topmost node or the no parent, which has no parent. This is known as the root. You already see in this structure the which has no parent. So you can see document has a parent, which is the parent root. Pictures also has a parent, which is the parent root. But root does not has any parent. So that is meant by that this root this value is known as the root ultimate one. You can also see the working folder has a parent called document. This family folder has a parent called this picture. So in a similar way, so the root is meant by that only. So the parent and child roots are represented by this. So this picture folder represents the parent and this family folder represents the child. So you can see with the definition as well. Okay. The leaf nodes that represent the bottommost elements which has no children. If you see clearly over here, the bottommost, if you see this file, the project.b.java, which do not have any children, this is known as the leaf node. But working folder has some two leaves or two children. So this is known as parent, this is known as the child, but it has also other name called leaf nodes. So this is known as leaf node, this is known as leaf node, this is also known as leaf folder, this is leaf file, this is leaf folder. Because this working folder is not a leaf folder because it has two child. The bottommost elements which do not have any children is known as the leaf nodes. So you can see this thing, this are known as leaf nodes. So height and depth are known as the what is the length of the tree, what is depth of the tree, and what is the degree of a node. So the count of its immediate child nodes. So the number of child nodes is known as the degree of the tree. Degree of a node. If you see clearly over here in the diagram, so you can observe all the stuff in a single image. So this is known as root. So the root node will be in the position of level 0. In the next level is known as we can have two elements if this is the binary tree. Okay, only a single parent can have two children in the binary tree, because that binary means 2. So single parent can have only two children. So this is known as level 1. So after that B has 2 children, C has also 3 children, as this is not the binary tree. So parent node, this is parent node D, which has 2 children. These are known as child nodes, and this complete tree is known as the subtree. So I, J, K, F, G, H, these are all known as the leaf nodes, because these I, J, K, F, G, H does not contain any further nodes, further subnodes. A is known as the root node. We already know about that. So see clearly, if you want to understand what is meant by degree of a tree, so you can see with the help of this simple GIF. So you can see the C node C has degree 1. Why? Because it have only one children. Now you can see all the leaf nodes has degree 0 because does not contain any children. So A has degree 3 because it has 3 children. So B has degree 2 because it has 2 children. C has degree 1 because it has only one child. So in that fashion, you can see again this animation. If you want to see animation clearly, you can also pause the video and or go back through the video and see this animation clearly. So whatever the node you are there, it has showing the degree of that node. So C has 1 degree. So all the leaf nodes has degree 0, and root node have degree 3 because it has 3 children. I hope this makes some sense. You understood now. So how to create a tree, or how to know whether it is a tree or not. So I have explained already what is meant by the node. So node is a ultimate thing. With the help of the nodes only you are going to create a tree. You can see how to store the data or values. Okay. In the left side we have the previous node pointing data, and the right side we have the right side pointing data. Currently this is the node. Inside this we have some data. In the right we have right pointer. In the left we have the left pointer. Sorry, this is the right pointer, this is left pointer, currently initialized with null. You can see with the help of this class I am going to create the int data, means this data node which is a pointer. I am naming it as the left, means this one. So node which is a pointer, and I am pointing to the right, which means this one. Okay, in this fashion you can create a node. Now you understood how to create a node. Now I will explain how to create a tree. So basically with the help of that nodes, so arrange all that nodes here like this. So basically this node having null. So you can see all of arranged like this, which are having data null. So you can see I am this is the root node. So in the root node, the left pointer I am taking 105, means this pointer. This 105 is pointing here. So 110 is pointing here. Okay. 115 is pointing here, 120 is pointing here, 130 is pointing here, and 140 is pointing here. And these are leaf nodes which does not have any further children. So you can leave the left pointer, right pointer as null in each and every leaf nodes. Okay. So this is the complete tree in the Java. So you can see if you want, you can also represent in this fashion in these lines also. But ultimately if you once connected with the help of the left and right, that's it. That is logically connected. But if you also see the visual representation, this is the visual representation how the trees are connected. We can also understand with the help of the code as well. In this video only we will be going to see with the help of code. I will be in detail explaining the code. Okay. So before explaining the code, let's also understand what are the types of the trees in every language. Basically you are going to see these things in every language, like C, C++, Java, Python. Every language you are going to have these kind of structures only. So you can see the types of trees. We have binary tree, binary search tree, full binary tree, complete binary tree, perfect binary tree, balanced tree, and finally skewed tree. So what are these types of trees? You can see clearly over here. You can pause the video and you read it by yourself. You can understand, you can get to know about these simple structures. Okay. So there are 6 types of, you can simply say that. So you can say that every node has either 0 or 2 children. That is known as, or you can say no node has only one child. Okay. That is known as full binary tree. Okay. This is the thing. So you can see that every node has 0 or 2 children. You can see this parent has 2 children. This parent has 2 children. This one has 0 children. You can see it is following this rule. And this children has 0 children, so this is accepting this one. Okay, this node accepting 2 children or no children. So if you see the complete tree, it is saying that all levels are completely filled except the possible at last level. So you can see that the last level is filled at the from the left to right. Okay, so you are going to start filling from this side. So first you fill left, fill right, fill left, fill right, fill left, then stop if you does not have any elements. So don't fill the right first. Okay, so what is meant by perfect binary tree? So all internal nodes have 2 children. Okay, it has 2 children, it has 2 children, it has 2 children. This is known as perfect binary tree. All leaf nodes are at the same level. You can see all leaf nodes have at the same level. So what is meant by balanced tree? So this balanced tree is also known as AVL tree. Why it is known as AVL tree? That is known as because we will see that in the upcoming sessions. So degenerate means the random order. So binary source tree, this is very important thing. So here 5. So in the left side it has to be the small number. In the right side it has to be large number. You can also read all the definition in the complete details by pausing the video. So binary tree having at most 2 children, full binary tree having 0 or 2 children, complete binary tree completely filled, perfect binary tree having 2 children or leaf node. Okay. So in this all the stuff, this binary source tree is very important because the left subtree has the smaller values than the root node, and the right subtree has the greater values than the root node. So other than this, we have something known as heap tree, AVL tree, red black tree. So you can also see the same stuff here also. So I explained degenerate. So I explained what is meant by complete. So full. So complete means you are going to start filling left, right, left, right, left. So full means you are going to start left, right, left, right, left, right. But there is no compulsion that you are only need to fill from the left, right only. You can also fill wherever the position you want, but compulsory you need to have 0 or 2 nodes. So in the balanced also, that is AVL tree. In the perfect means all the stuff has to be in the same level and same number of nodes should be there. Okay, and 2 power n nodes should be there. Okay, 2 is there, 2 to the 2 power 2, which is 4. But in this case, that's not the case. Here already you have completed the 2 power 2, but here you need to get 8 elements, but here only getting that 4 elements. So this is the difference between full binary tree and perfect binary tree. Now we have understood what is meant by the complete, full, degenerate, these and all stuff. We understood what are the types of trees we understood. Now we should understand what are the traversal. What is the traversal? Because you have created a tree, but how you can see the what is the elements in the tree. So how you can see the elements in the tree, that is with the help of the traversal. Basically you have 3 types of traversal and other 2 types of traversal also. So in the 3 types of traversal we have something known as pre-order, we have in-order, we have something known as post-order. So let us understand what is meant by pre-order. So I will explain with the help of the shortcut. So you can see the blue dots. I hope you can see the blue dots. So each blue dot you can see that is known as pre-order. Okay, you can see the ultimate order. So the ultimate aim is to print all the stuff what is there in the tree. You can have to print that in the terminal. So that is the ultimate goal. So with the help of the simple stuff, you can see we are going to check whether root is equal to null. No, it is not equal to null because we have some stuff A here. So we are first printing the data because we are at the point A. You can see blue dot. Blue dot means print. You can see system.println means print. You can see with the name itself. Pre means print. Pre means left side. You can see print. So print. You can see A, B, D is printing. A, B, D is printing. Next H is printing. Here you can see H is printed. Next come. You can, whenever you see the blue dot, print that. So you can see blue dot means I. You can print that. So next come. You can see blue dot E. Print that. So I'll come in this fashion. You can see blue dot C, blue dot F. Print that C F. So like that you can come like this here. You can see the blue dot on G and G and J. You can print G and J. So you can achieve with the help of the recursion. First you need to go towards ultimate right, ultimate left. So you can see we are going to ultimate left. So after that you are going to ultimate right. So you are slowly going to the ultimate left, right. First you are going left. After that you are going right. So this is known as pre-order. So in the same fashion, if you want to print in the in order, so wherever you see the green dots, that is known as in order. So you can see first if you want to go to all traverse and you have to print the stuff, you can see in the code as well. So first of all you need to traverse all the stuff towards the left. So after that you need to start printing with the help of these green dots. So H, D, I, B, E, A, and come here F, C, J, G. You can see in the help of the same order that I am saying here. You can also compare the stuff green dots and here also the same order. Okay, ultimately you are going to the right. First left, print the stuff, go towards the right. Okay, so the last and final traversal is post traversal. So you can see what is meant by post traversal is wherever you see the orange dots. So pre traversal means the left side. So in order means the underneath of the node, and so post traversal means the left or the right side of the node. Okay, the post, the right side, orange node. So you can see, so come here, the orange node seen here. So H, so after that H you can see I here. So you can follow the arrows how I am following. So D we have, E we have, B we have. So come here, F we have, J we have, G we have, C we have. So finally we are printing A. You can see the same order that what I have said now. So by seeing this diagram you can simply understand what is meant by pre, in order, post order traversals. So you can say why these orders are different, because the ultimate aim is to print something in the terminal. All the elements has to be printed in the terminal. Whatever the logic you follow, whatever the way, whatever the order, that doesn't matter, but you need to print all the stuff in the terminal. So you can see first we are going that left, and next we are going to the right, and after that, so left, right, print, left, right, print, like that, left, right, print. That's the stuff. So finally we have something known as level order traversal. In the graphs we will be going to use this level order traversal. As the tree is also a graph part, you can see we have two types of level order traversals. One is BFS and another is DFS. So what is meant by BFS? So BFS is you can follow the arrows. So breadth wise we are able to printing. So the level 1 first we need to print. After that level 2 we need to level 0 we need to print first. Level 1 print next. Level 2 print next. Okay. So if you want to see the output, I will reading words. You can see the output here. So you can see for it print the level 0 first, that is 0. Next print level 1, that is 1, 2, 3. Next print the level 2, that is 4, 5, 6, 7. So basically this is a tree. In the BFS breadth for search, so you are going to print 0, 1, 2, 3, 4, 5, 6, 7 in the level wise. Okay, you are going to follow come in this fashion. But in the DFS depth first search, how you are going to print is you are going to print the level wise. So okay, ultimately the orders may be different. You can see the output is different here, output is different here, but ultimate A is to print something in the terminal. Okay, something means all you need to print all the stuff with the help of some logic. You can go up to the depth, you can go up to the breadth, that is your according to your wish. Okay, so if you follow the arrows, so you can see first I am printing 0, next 1, next 4, come back 5. So go back, so you are going to print 2, you can see 2, then 6, go back, so you are printing 3, you are printing 7. So again see the stuff here. You can follow the arrows while I am reading this stuff. So 0, 1, 0, 1, 4, okay, 0, 1, 4, 5, 2, 6, so 0, 1, 0, 1, 4, 5 here, coming back, so 2, 6, okay, next we have 3, 7, so come back 3, 7. So this is the complete tree, complete pack. Now we are going to unpack. We need to see the code so that we can understand in detail about how to create a node, how to manage insertion, deletion of each and every node. Okay. Okay. Currently now I am in my VS Code. So in my file called demo.java, inside this I have inside this class demo we have a main method. Okay. Now inbuilt there are like let's say. Okay, let me create a binary search tree for you. So in this code we are going to create a binary search tree. We have many trees we have seen. So out of all those stuff we are going to create a binary search tree because the left side of the data will be less than the root node, right side data will be greater than the root node. That's the thing that we are going to create. So what I will be going to say is I will say binary search tree and I will be going to create an object and I will be going to say new and I will say binary search tree. Okay, this makes some sense. I hope you know how to create this object. Okay, I am creating a reference object of binary search tree and I am creating a new object called for this class binary search tree. But you are thinking now there is no object, there is no class for this binary search tree. Yeah, there is no class. So if you hover over that, you can see quick fix. Okay, it will be going to show all the methods that you can erase this error. So you can say create a binary search tree in the demo. No, create class in binary search tree in package.java. Yeah, I have a package called Java. So package means here folder. So you simply if you click that. So for you it will be going to create a folder called binary search tree.java. So if you come inside that, you can see clearly I will be going to erase this. So for your understanding, I will be going to take this here. Okay, I will be going to close this folder structure. So now you can see this both of the folders in a simple way, both the sides both, and you can see the terminal as well. I will write in this afterwards. Okay, or I will close this first. So you can see we have two folders, that is demo.java and binary search tree.java. Now in this I am creating an object for this class. Okay, binary search tree class. So I will be going to make this as public. I will make this binary search tree as public and in this we are creating an object. So we'll come down. So we will say BST. So for the object BST we are going to say dot insert. So I am going to insert some number, example say 50, but we do not have a method called insert. So I will come here. Okay, I will quickly come here and I will be going to say public void insert. Okay, this will accept an argument, so I will say int value. So after that open the braces. Inside that you are going to say root is basically we do not create the root because we know that the tree execution will start from the root. So root is also a node. So first of all you need to create a class for the node. So without creating a node, how can you create a root element itself? So I will be quickly going to create a class for the node. So inside this we already see in the presentation that we need to have the data. Okay, we need to have data for the node and we need to have the left pointer and we should also have the right pointer. Okay, so I had both the pointers, that is left and right pointer. So I will come down, I will be going to say node. So it will be going to accept a value. Okay, it will be going to accept, basically I am creating a constructor because for this reference of node I will going to construct a constructor. So in this we are going to say the data is equals to value that we are accepting inside this argument. Okay, So this constructor will be initialized whenever you create an object. Say you are creating an object here. So whenever you create an object, this data will be gone inside this data, and after that you are going to initialize the left pointer with the null, and the right pointer also you will be going to initialize with the null. So I hope there is no issue in this creation of this the node. So we have already discussed how to create a node in the PPT, and here just you are creating a constructor that you can able to have the values first ever when you create an object itself. So I will quickly come here and I will be going to create a root itself, because all the execution will start from the root. Root is of type node. Okay, we are I will be going to create the element for root, because if you know the linked list concept, here in place of the root will be going to create a node called head, and that will be initialized with null. Okay, but here we are initializing the left and right with the null. Okay, because we have in the root node we have left pointer and right pointer, because we have the reference of the node. Okay, so after that in the insert, what we are going to do with the help of this value, we are going to insert inside this with the help of inside this binary source tree, we are going to insert these values for the left and right. Okay, so I will come here inside that and I will be going to say root is equals to insert with the help of recursion. Basically this is a function which will take a root value and which will take a value. Okay, place the semicolon. So this value is coming from here. So this root already we have created, but what is this insert recursion? So this insert recursion is a function that we have not created up to now, so we will be going to create that. So okay, so come a little bit down. So or you can quickly hover over that, it will be going to quick fix. So create a method. Okay, it will be going to create a method in the private sense. So just remove this line. So for simplicity I will be going to show only majority focus on this code. Okay, now what you are going to do is inside this, so missing return statement. Okay, that is directly created, right? So the return type is here we have created node, so we are going to return a node pointer which will be root. Okay, so first of all inside this recursion type we are accepting the root node. It is inbuilt. I just quick fix and get this value, so don't create that. Just we are what the value is coming, you can simply change that to current. Okay, so whatever with the value you are accepting, the same value you are going to check is that null or not. So if that is the null, if the root node itself is null, what you are going to just say return new. With the help of new keyword you can say new node dot what the value you are accepting inside that, what the value you are accepting inside the value, taking the value. If the current node means what the root value is null, simply return a new keyword. Okay, so finally after comparison you are going to compare as this is the binary search tree. After the simple comparison you are going to again compare with the value is that is less than equal to the current dot value, current dot data or data or value, that is your wish, because if you see clearly over here we are saying that is as data. So if you name it as value, you can name it as value, that is your wish. So inside this if statement you are going to say, so current dot right is equals to insert track. Inside that insert track what we are going to pass is current dot left, and we are going to pass the same value. And okay, this is for the left subtree, and in the same fashion in the else if also we are going to check for value is that value. I hope you know the concept of the binary search tree. The root node has to be the bit in between element, and the left subtree elements has to be the smaller elements, and the right subtree elements has to be larger elements. So the same thing I am comparing here. So is that value means the value that we are getting is that the current dot data means this is the root node value. Okay, is that the value that we are getting from here, that is 50, is that equal or the less than to current node value. If the current node dot value is greater than the value that we are getting, okay, getting here we are 50. If 50 is the small value than the current data value, just place that value in the root left side. If that is greater, here that we are going to check with the help of this statement. So we are going to say current dot value or current dot data. Okay, if that's the scenario, then place simply this statement only. But sorry, here we are going to say the left, because we are placing this data in the left only, right? So copy this value and place it here. So inside this we are going to say the right value, because this is for the right subtree. Okay, change here also. So finally you can return the current pointer. That's why it is showing the error here. You can see over that it will be going to say missing return statement. Okay, you can simply you can return the current. This will be going to completely complete this function insert track. So recursively it will be going to check whatever the value that we are inserting with the help of this function. So this insert will call this insert recursion. So inside this insert recursion, it will be going to check all this stuff and it will be printing in the stuff. So basically, if you see clearly, what I did is after creating this insert recursion, so I created two functions called, one is for the in order and the second one is for the in order recursion. So we already know about the in order recursion or in order, pre-order, post-order. In this video, I am going to show with the traversal with the help of in order. Okay. So in this in order, just I am going to call this in order recursion and I am passing the root value as this is the global thing. So after that I am printing a separate line. Okay. So after that I am in the in order recursion, I just checking is the root is equals to null. No, if that is the case, so simply you are going to return. If that's not the case, you are going to first traverse to the left and you are print the data and next traverse to the right. Sorry, this would be right. Okay. So in this fashion, first traverse left, print the data, traverse left. So you can see in the demo, if I come to again to demo.java here, so I have inserted one value and I am printing in order traversal. If I compile and run, you can see it is saying in order traversal and printing the value. Why it is saying that? Because I am printing in order traversal and I am calling the in order here. So this in order will call in order recursion. This in order, in the in order recursion, we are printing the data current dot data here. Okay. If you try to insert another data, let's see. If you try to insert so much data, so this is the data that you have inserted. Now let's see what happens. So if I compile and run, so you can see it is printing all the in order traversal data. You can see it is printing 12, 50, 250, 49. So it is printing according to the order that we not inserted. It is not the linked list. It is not the array. It is basically the stuff that is what we have understood according to the theory. You need to revise to the PPT and you can check what is the order it is printing here. The inserted order is not equal to the order that is printing here because this is in order traversal. See, we are inserting 12 at the last, it is printing 12 at the first. So that's not the case that you are inserting 469 at the last button, but it is printing at the last. Why it is printing at the last? Because due to in order traversal. So the concept you can revisit that, or you can have a graph inside that, and wherever you touch the bubble, basically the circle, wherever you touch at the bottom, that is the in order traversal. You can see here also. So travel up to the left, print the element at the bottom, or touch the element at the bottom. So finally go to the right. So you can also see here, first of all go to the left and go at the bottom, you can touch with the green bottom. So H, D, I, B, E, A, F, C, J, G. So in this fashion, how the bottom green ball is touching, that is known as the in order traversal. And I hope you understood this video how you can traverse the whole tree with the help of the in order traversal. So the similar version, but these three orders will be interchanged. So you can see, so in the up to now we have seen the in order. So first you are going left, printing the data, going right. So in the pre-order you can just first print, go left, go right. So we are in the post order, first of all go left, right, print the data. See, this is the simple difference between the in order, post order and pre-order. So I hope you understood the full trees. So thanks for watching up to now.